The bent rod ABDE is supported by ball and socket joints at A and E and by the cable DF. If a 60 pounds load is applied at C as shown, determine the tension in the cable. The first thing you need to do is to draw the free body diagram of the figure, then solve the problem. First, we need to find the points between the D and F. The x-axis we have 16, negative 16, I, plus the y-axis we have 11, 11j. The z-axis we have 8, negative 8. Okay, then next is to find the magnitude of the df. Square root of negative 16 squared plus 11 squared plus negative 8 squared. Square root of negative 16 squared plus 11 squared plus negative 8 squared. 21. So, it's equals to 21. Then, the df. T times df over the magnitude of df was equals to T times negative 16I plus 11J minus 8K hat over magnitude we have 21. Next is the points between the D and E. D is in the x-axis we have 16, 16I. Though y-axis we have 0, so then the z-axis we have 0 also. So then the points between C and E. CE. CE is in the x-axis we have 16. C 16. 16I. In the y-axis we have 0. And in the z-axis we have 14. So negative 14. Okay. To solve the tension of the cable, we solve first the points and the magnitudes of the DF, the DE, the CE, and EA. So REA is equals to EA over the magnitude of EA. So in the x-axis of EA we have 7, and then in the x-axis we have, in the z-axis we have 24. So the magnitude of EA is equals to 25. We take the moment of EA to solve the tension of the cable. So is equals to R EA times DE times D plus R EA times C CE times the negative 60 pound J is equals to 0. Next is we have to matrix the points I, J, K. In the DF, EA. First is the EA. 7, 0, negative 24. Next is the DE. DE, 16, 0, 0. Then the DF, negative 16, 11, negative 8. Times the tension. So T over 21 plus times 25 plus REA 7, 0, negative 24. Then the CE 16, 0, negative 14. The negative 60. One over 25 equals 0. We need to solve this first. I, J, K, 7, 0, 24, 16, 0, 0, negative 16, 11, negative 8, 7, 0, negative 24, 16, 0, 0, negative 16, 11, negative 8, I, J, K. First is this and this. So 0 times negative 16 is equals to 0. Then negative 24 times 0 times negative 16 is equals to 0 too. So 0 minus 0 is equals to 0 I. Next is the J. J. negative 24 times 16 times 11 is equals to negative 4,224. The 7 times 0 times 11 equals to 0. So 0 j hat plus decay. So 7 times 0 times negative 8 is equals to 0. 0 times 16 times negative 8 is equals to 0. So 0 times 0, 0 minus 0 is equals to 0. So we have positive minus minus positive 4,224 t over 21 times 25 plus, next is you need to solve this side. So 7, 16, 0, 0, 0, negative 60, negative 24, negative 14, 0. 7, 16, 0, 0, 0, negative 60, negative 24, negative 14, 0. I, J, K. I, J, K. So 0 times negative 14 times 0 is equals to 0. Negative 24 times 0 times 0 is equals to 0. So 0 minus 0 is equals to 0i. 0i. J. Negative 24 times 16 times negative 60 is equals to 23,040 minus 7 times negative 14 times negative 60 minus 5,880 j hat plus 7 times 0 times 0 is equals to 0. Negative 24 times 0 is equals to 0. So 0 minus 0 is equals to 0. So 0k. 0k over 25. So 20,040 minus 5,880 equals to 17,000 plus 17,000 160 over 25 is equals to 0. Cancel both 25. So, divide 4224 by 21. 4,224 divide 21. So, we have 201.14 T plus 17,160 is equals to 0. We have negative 17,160. So, transpose this to the other side. So, 201.14 T is equals to 17,160. So, divide both sides by 201 to get the tension of the cable. T is now equals to 17,160 divide 201.14. We have now 85.31 pounds. So here in the figure, the tension is 85.31 pounds.